Hello, everybody. Thank you for joining us today. My name is Patrick Moran. I'm from the marketing team at H2O.ai. And before we get started, we'd like to do a quick sound check. If you could please type into the questions tab if you are able to hear us clearly. Once we get a few responses, we'll go ahead and get started.
Great. Well, thank you, everybody. Thank you for joining us here this morning, this afternoon, or this evening, depending on where you're at. I'm Ingrid Burton. I'm the CMO and an AI transformation leader at H2O.ai, and I have with me today.
I'm Vinod Iyengar. I'm the leader of data science transformation here at H2O.ai. I'm really excited to be here.
Yeah, so what we wanted to do today is really share with you some key takeaways for the C-suite from what we've heard from a number of customers, people we talk to in the industry, and talk to all of you about what are those key AI takeaways. So how do you embark upon an AI strategy if your company has not started? And that seems to be a common theme today as we move to seeing more AI and machine learning use across enterprises. A lot of business leaders, from the CIO to the CDO to the Chief Analytics Officer and even the CEOs, have a lot of questions on what do I do next? And so today what we wanted to do is share with you some of the key challenges, the opportunities, and just 5 things you should start looking at or thinking about. So with that, I'm going to take it away. So the challenges today in AI, which are really, we're at an all-time peak in terms of interest that we see in the industry. There's a lot of reports, there's a lot of news out there around AI. But the bottom line for many businesses today is that there are 3 key challenges in embarking upon an AI strategy. First of all, who? Where are you going to get the people? The talent question. Where are the data scientists? How do I embark upon this journey if I don't even have a data scientist on my team? So that's a main question that reoccurs regularly, and we're going to talk about that today. The second thing is maybe you have a data scientist, or maybe you have one, maybe you have a team. The element of time comes into play. So it's really important to understand that it's not a quick fix for your business. There isn't a fast way to just go upon an AI strategy and you're going to get results instantly. We would say that there's a time element, and we want to address that time element today and talk about how you get to faster results, because it's all about getting business results. It's not about AI per se. It's what can you do with it. And so how do we cut the time to getting to results? So time is a challenge today. And then there's a lot of questions around trust. How do I trust the models? How do I trust in AI? How do I explain this to regulators? And we have some opportunities to discuss that today as well, and we want to address that. So the talent, time, and trust challenges that exist today for businesses and when they think about an AI strategy are clearly top of mind. So the 5 key things that we want to start with is, first of all, we've met with a lot of CDOs and a lot of chief analytics officers, so chief data officers, digital transformation people at some of the who's who in the Fortune 500, definitely in the Fortune 100. And one of the things that we clearly have heard from even just some prospects recently is you got to start with a data culture. You know, when you start thinking about AI, you can't get to an AI result unless you have data. And you can't get to that unless you really embed data and a data culture within your company. If you're looking at, you look at the screen, data, we've regularly been looking at data for decades. A lot of you have gone through a data transformation, and data just exists everywhere. So how do you tap into that data? How do you get to a data, a data transformation, a digital transformation, and then harness it for AI? So it really is a key challenge in order to not only think about it, but think about, who in your company is going to embark upon this AI transformation. So, Vinod, we talk about data as a team sport. Why don't we elaborate on that a little bit?
Yeah, it's a great point, right? So, as Ingrid mentioned, we are living in a time where there is a lot of data being collected. So this is primarily a function of how our business is organized, and enterprises are now collecting data from their marketing sources, from the sales mechanisms, from the way the products are being built, product monitoring. You get customer analytics coming in through all these different sources. So everyone has the ability to collect data. So that's first, right? So building a data culture means you proactively start collecting data first and putting it in a format which is then easily accessible. So to create a data culture, you need to be able to make it really easy for people to see the data and actually get insights from it. Now, how do you do that? To do that, you need to train the people on the team to be able to take advantage of data sets. Now, you don't need PhD level data scientists or machine learning researchers on day one. When you say it's a team sport, what you mean is that you need people of all different types of skills. You need to build a whole sort of slew of people. You do, of course, want the experts who can build sophisticated models and algorithms, but you also need people who can just look at the data and quickly get a sense of what's useful or not. So when we talk about team sport, we're talking about building people with all kinds of skills and also up-leveling existing people. So your existing marketers, your existing finance people, existing product people, can they become data aware or data science light, if you will, right? So how do you do that? First, giving them the basics of data science, like telling them, like, how do you make assumptions? How do you ask the right questions? And we'll come to that in a bit, but creating that sort of culture of up-leveling everyone to be data aware and also start asking those questions from your data.
Yeah, so we were talking recently to a CDO and a CIO of a company in LA, and they were starting from the standpoint of they had data, but their company, their culture was data averse. And so they had to collect it all into a single place. They had to create dashboards. So they just started on their journey, and now they're going into AI. But they really were at this point where, the people that have been around for decades within the company are like, I know my gut feel. I know I know what's going on in the market. I know my customers. And when presented with data, it turned out that they were, off by a few percentage points and more. So really embracing data as part of your culture is important. And, we look at the cultural transformation of getting to AI, and I think there's a number of reports on this now, is really a key driver. You really have to understand as a member of an executive team that you can't just mandate AI. You can't just mandate digital transformation. I think a lot of you know that. What you have to start embracing is, what can you glean from the data? What can you find out from data that also augments, that gut feel that we all have? I mean, we've all been there, right? I think I know best. Data can tell me that I'm a little off or that my gut feel is correct. So it's good to know that. So when you think about who's on your team, we look at it as, kind of a triumvirate, so to speak. There's the business leader, right? The business leader, probably one of you in the C-suite. It's, the CMO, it's the chief revenue officer, it's the officer of risk management at a bank. They are trying to solve a business problem. And we'll talk about that a little bit, but the main person is, we're not doing this because we're just having fun. We're doing this because we're trying to solve business problems, get answers to the business, and they rely upon a data science team or an analytics team. So the chief data officer, the chief analytics officer come into play here, and they want to know, how do I arrive at the best answer for the business? So they have to work in concert together. And then, of course, IT is important, is so imperative, because you can't just drop new software or new processes into an existing system without IT really knowing about it. It becomes a real problem, right? So the CIO needs to be involved, and we really look at this as this is the culture that you need to start creating. is this is a team sport. People have to work together. They have to realize that they're deciding on outcomes. We're not trying to mandate AI. We're not trying to mandate digital transformation, but we're trying to look for answers so that a company can get to a competitive edge. So the first key takeaway here is, build a data culture. Takeaway number one, who's on the team? We also find out that, you might have the right talent within your organization already. So you have probably really smart, excellent people that want to be part of that team. This is something that we find to be true in almost every company that we talk with, from large telcos to media and entertainment companies to banks. They have really smart people that want to become well versed in becoming part of this data culture. And of course, it's part of this data culture, data from every facet.
Yeah, and just to, if you think about it from a tactical perspective, what we've seen some of the best sort of mature organizations they've done, and they didn't start a whole lot earlier. They've started maybe a few years ahead of you maybe, but all they did is create first a center of excellence of data science or people who are data aware, and then build around them. So you can do it two ways. One is, if you look at the sort of the triumvirate that Ingrid talked about in the previous slide, you can have a cross-functional data science team that is basically permeating all the different organizations. So our CEO always likes to say, put a data scientist in every org if you can, or in every group that's making a mission.
Attach a data science person, right.
So what that means is really that you have the data thinking permeating for the entire group because of this one person who might be an expert. And that way you can slowly sort of build this mentor-mentee model and have more and more people surrounding them who started picking data science skills and become sort of users of data and consumers, and then start going one step ahead, creating insights of the data. The second way sort of you do this is sort of like Ingrid mentioned, up-leveling your existing team. So you have people who are, say, business analysts, who are BI analysts,
yep.
Who are folks who are doing data warehousing, for example. These are all people who've been working with data. They know the intrinsic structure of the data, how the different things combine together. So you can possibly send them to boot camps, or send them to one of our conferences, like we do a user conference all the time, or send them to any trainings, online trainings like Udacity or Coursera.
Yeah, Coursera has some great courses on training people in data science. Yeah, we would totally recommend that.
But give them the opportunity to up-level, and you find that some of these people are already working with data, they will be able to pick this up really quickly.
Very fast.
And that way you can sort of cut the problem by sort of up-leveling your existing force who are already sort of trying to get to the next stage in their career. So there's different ways, and whatever works best for you, but I think having that awareness up front and trying to build the data culture in a proactive fashion is critical.
Yeah, absolutely. So key takeaway, build a data culture, figure out who's on the team, find the right talent within, and be very data focused. Okay, number two. This is key takeaway number two. You really got to ask the right questions, right? So if you're a major bank, or let's take a retailer, what are they trying to solve for right now? Recommendations, offers, personalization, know their customer. They all have these questions. Every major bank has, like, how do we detect fraud faster? How do we do KYC, which is know your customer? How do we detect money laundering to thwart that with anti-money laundering? How do we get to those questions? And so, yes, there's early adopters in many different industries, but there's so much low-hanging fruit in terms of just finding the answers to questions you already have. You already have these questions. How do I, get that next customer? Who is that next customer? How do I optimize my supply chain? How do I cut out transportation costs in the supply chain? You can get down to very granular, detailed questions. And so asking the right questions is imperative. So part to thinking about creating an AI strategy is, as Vinod said, you need analytical people, right? You need analytical people, mathematicians, statisticians. These are not computer scientists per se, okay? So this is a different skill set. This is problem solvers. These could be business analysts that are ready to be part of an AI strategy within your company. I would contend, and I always like to put this in, I think you got to be really creative. You got to think outside the box. You've got to find people, you yourself, your company, have to think about creative solutions, meaning the same old way isn't the way forward. or maybe it's part of the way forward. But you've got to be very creative and open, really open-minded. And of course, as Vinod said, you really got to be data-driven. Your data is everywhere. We've talked about this. You know, sometimes companies don't realize how much data they're generating. Look to the marketing department for sentiment analysis of, you know, what's going out on social. Look to the finance department to look at the transactional data that you have. Look to the engineering department or support functions, you know, the innovation functions within your team to hear feedback from your customers. Data is everywhere, and so you can harness it to answer the questions that you may have, finding that next customer, making a recommendation. All of that is possible with machine learning. All of that is possible with AI, to getting closer to the pin, so to speak. You know, making sure that you're spending your money wisely and getting those answers. So we're going to talk a little bit about use cases. So if you're embarking upon an AI strategy and you're in one of these industries, and by the way, AI and machine learning are now in almost every industry that we see. We just gave some examples here of what customers are doing, customers that we work with, people that we know that are doing things today. So in financial services and banking, everything from, you know, credit cards, so credit companies, new credit, retail banking, wholesale banking, also hedge fund management. The list goes on. Bond trading, we've got customers in almost every segment of financial services. Then healthcare and life sciences, just really amazing results happening with predictions around sepsis detection, so disease detection. Better patient outcomes are being had because of AI. So I personally am very passionate about that. Is if we're going to save somebody's life with AI, it was all worth it. Telcos, you know, predictive maintenance, avoiding truck rolls, next best customer, customer churn prediction. Marketing and retail is just so, you know, it's almost like you have to have an AI and machine learning. We're working with a number of retailers right now and digital marketing firms on, you know, next best customer, funnel predictions, personalization. It's all very important. What's the point of all this? Save time, save money, make money, and really gain a competitive edge. What we're looking at right now within our own customer base is, if you aren't doing many of these use cases right now in your particular vertical, you may be left out, and we don't want that to happen. So it's really critical to really think about, these are use cases, but they are problem solving, right? They're, you know, we're using our algorithms to provide you with answers. You have a problem, we're giving you a prediction with our technology. So think about that. I don't know if you want to add to that.
Yeah, it's a great point. So it's important to ask the right question, and more so with machine learning and AI and data science in general, because typically when you are framing experiment, you're basically asking a very specific question. So if you were taking like a stats class, you always talk about what's the hypothesis that you're testing. And you're either trying to prove the hypothesis or disprove the hypothesis, right? That's basically from what boils down to data science. You're typically trying to ask a question and try to prove that a question, whether the answer is true or not. And so that means that you have to ask the right question. For example, in the CDO summits, we heard a CDO jokingly say that their management comes and asks, "Hey, can you just throw some AI on the problem?" And that's a good example of where you are not aware of what question to ask, and so you'll get these sort of naive questions. But the reason we
let me pause on that. So at a recent CDO summit that we were participating in, you know, the one CDO that was sitting there was like, his CEO comes to him on a regular basis and says, "Can you just throw some AI at that? You know, just sprinkle some AI on that." Yeah. That's not helpful, right? So go ahead.
Yeah, so exactly. So that's why we present these use cases to sort of present the art of the possible, right? So, and oftentimes these use cases are not just restricted to the vertical, right? You can take, for example, fraud detection can be applied across different verticals, right? So, but the key here is to say, the question here you're asking is this transaction a fraudulent one or not? Or is this person a fraudulent person or not? So when you frame that question in that sense, then you know what data to collect, because the data you collect for a particular problem is very, very dependent on the question you're asking. So if I'm trying to predict what's my sales forecast for the next 12 months. If you're a head of sales or or even a CRO, that's a question you're probably asking. So then the data that you want to collect to answer that question is very, very specific. You're going to pull in all your historical sales information, the customer information, the type of customers, and their interactions with your team. So once you have that information, then you can answer the question effectively, whether you can forecast the next 18 months or not with some degree of confidence. But the key, again, is to frame the question. So how do you do that? How do you bring that culture in? So it goes back to the previous question. You have to keep educating your people to think about their high-level problems. So as Ingrid said, every business wants to save money, make more money, and save time, possibly, right? So these are not different for any business. But how do you then sort of peel the onion back to say, hey, how can you as a business owner or a person in a critical functionality translate that high-level goal to a question that you can ask your data off of? So having that sort of culture of asking these questions and sort of learning from what others have done. So it's often useful to see, like on our website, for example, we published about 100 use cases, and those are just a way to sort of spark the conversation. You might think, oh, I have customer data, I have sales data, I have information on what people are doing on my website. So everyone has web analytics, for example, right? So there's like, what are the 10 questions you can ask off of your web analytics? Like, you can predict whether someone's going to buy a product, whether someone's going to click on an ad, whether someone's going to drop off the website, how much time will someone spend? So these are questions that you could ask, and once you ask a question, you will then realize sometimes that, oh, I actually don't have all the data I need for that particular question. And that then can trigger a question to the IT or data science person, hey, how do we collect this data? So sometimes you might have data.
You might find that you need to do more.
Correct. So asking questions is absolutely number one, because if you ask the right questions, that then determines what outcomes can be generated out of it. And then you can actually measure whether the experiments are successful or not. Because if you don't set the right outcomes, the right questions, your success metrics are all over the place. They are probably generic sometimes at worst. Worst case, they're probably wrong, right? So, so if you don't set the right metrics, the right success, and the right outcomes, you're not going the right direction. You don't even know which direction you're going in.
Yeah, the other thing that we hear a lot is try a number of things, right? Ask a number of questions. Don't just focus on one. You know, how do I add more customers? It's almost too broad, right? So you need to ask a number of questions to get to answers. So key takeaway number 2 is ask the right questions. Realize, what problems are you trying to solve? It's not just about sprinkling a little AI on everything. That's not going to work, or that would be a different approach. But what problem are you solving? Also determine outcomes. Measure your success and keep refining, right? You're never done. It's just like everything else. It's constant iterative approach. Determining outcomes. So like if you're saying, I want to minimize my fraud detection in this part of our business, or minimize fraud in this part of our business, a good outcome would be to increase our detection rate by, 2%, 5%? Put a measurement on it, because then you're going to be able to measure that success. And you're going to find out a lot once you start experimenting. So once your data science teams have the right data, the business is asking the right questions, you can start to see what you're looking for. It starts to emerge very quickly in front of you. So asking the right questions is key. So we have also some other things that we're finding to be very, very true, which is there's a lot of people that are in the same kind of situation where they're just starting. They want to learn. Learning is all part of this. So we talk about machine learning, but we make learning fun, because machine learning and AI are just one facet. Asking questions is the other, but learning from the community. Sending your people to be trained or do training. There's so many online trainings, as we said, but there are ways to connect with the community online. We, for instance, have a huge meetup community. So if you look up meetups and machine learning, or you come to our to our website, h2o.ai, you can learn a lot from other people. We share as much information as we can, and it's such a new field for many people. If you just share your knowledge and join a meetup or send your people to meetups and present, you'll find out there's great talent out there, number one. It's a great place to find talent. But you'll also learn so much from other people's experiences, whether it's a mistake or a success. We're all going to learn. So this is what we encourage people to do, is really join in the community, participate, really become part of the movement as we see it. So key takeaway number 3 is connect with your local community. So it doesn't matter where you are. There are community members in machine learning all over the world. We are seeing community involvement in Chile, in Paraguay, Uruguay, London, Paris, Prague, all over the U.S. and Canada, Mexico, Japan, Singapore. There are communities, India, there are communities everywhere. And so we want you to think about, once you establish your team's data culture, you realize who's on the team, you're asking all the right questions, share with others, participate with them, and learn from everyone. I think this is really critical for people's success. The folks and the companies that share actually benefit.
Yeah.
So I don't know if you have any more to add to this.
This is, in particular, I'm really excited about this because unlike previous sort of software movements or even sort of intelligence movements, this one is built on top of open source. So it's very uniquely AI. If you see the last 10 years, most of the cutting edge research has come from the academic community and from the open source community. So even large companies like Google, Facebook, or Microsoft, or HTO, for example, we are obviously for the forefront, but even the largest companies, the latest and cutting edge research that comes out doesn't go into their product in a closed source manner. It goes to the open source. The community gets to try it out first. And there's a reason, there's a selfish reason for this, because this space is so new. There are so many things that we are not aware of. We don't understand how things work, especially when you get to like some of these complex algorithms and technologies. So you really want the community to sort of crowdsource and peer review and tell each other that, hey, this is worthwhile, this is useful. And what you then see is some really amazing sort of cross-disciplinary things coming out. So, for example, a lot of the AI research has come out of sort of the biostatics space or the bioinformatics space. Similarly, we see some amazing research coming out of sociological sciences, right? So,
bio and sociological.
And those are getting used in completely different orthogonal verticals. So some of the algorithms from bioinformatics might get applied in marketing.
And that is happening.
Correct.
Some of our customers are taking bioinformatics and applying it, algorithms, and applying it to marketing and sentiment analysis, and into some of the banks. So it's really interesting to see the cross sectional kind of view of this.
Exactly, and some of it's really fundamental sort of function of what the data looks like and what the sort of natural distributions look like in some of these industries, right? And that's really tough to know even for experts till you try different things, and that's what the community has allowed you to do. There's also a second reason why you want to connect to the community. Most data scientists want to share and collaborate. If you try to build a close community, you'll find it really tough to retain your customers, your data scientists. They really want to share, and that's how they learn and grow as well. Because it is, and I read this tweet somewhere where it says, specific knowledge cannot be taught, but it can be learned. And data science is that. It's the cutting edge of research, and it's so new that you cannot really teach it in university, but you can learn it, and you learn it from the community. So if you close off your group, you don't connect the community, your people will sort of they will sort of atrophy, their data science skills are no longer. One great example, 5 years ago, the algorithms that were really popular when I started doing like SVM are not as popular now. Today there's a whole new batch of algorithms. And if I come from school learning those techniques and not connect with the community, I'd be stuck in a technique which was really old, which is old badly 5 years later, right? So you really want to interest to come into the community, and the community can be in multiple places. You have meetups in every city. You can be a sponsor of a meetup. You can go and encourage your employees to do the meetups, or you can host meetups in your office.
Let's talk about that. So you could host a meetup in your office. You can host a hackathon in your office.
Yep.
A number of our customers are doing that and inviting others in. So they'll do very public hackathons within their environment, and their data scientists and analytics people they're all learning from people that are walking in. And you also get the students coming in. So back to the talent issue, you start bringing in, if you start holding these hackathons, you'll be bringing in top data scientists that are just about to graduate or can do an internship.
Yeah, start an internship program, because unlike other spaces, interns actually might be really might have more latest knowledge than you might have.
Yeah.
So you might have business knowledge, but an intern might have the
latest algorithm. Yeah.
And they can come and teach your team something that you might not have been aware of. So connect with the local university, maybe start an internship program where you can have batches of these data scientists coming in and interning with you, maybe take a crack at some problems that you're not trying to get to.
Every university out there is focused on this. We actually have a free academic program, so we're giving out licenses to students and researchers and universities and professors, working with them on creating curriculum, but also more importantly, what that means is we're creating the talent pool.
Yeah.
Helping people create the talent pool is really important to us. So the community, if you connect to the community, you're going to see more of these people out there, which is going to help you staff up, regardless of who you are or where you are. Another thing is we talk to a lot of Midwest companies, let's say. So coast to coast, there's always a lot of great talent, obviously. There's also some great talent in the Midwest in the U.S. I would say Latin America is coming on strong.
Yeah.
A lot of data scientists there.
Yeah.
Very interesting to see
we
that.
Japan.
Japan.
From Belarus, we have grandmasters from Singapore, from India.
Yeah, so
there's
the community is a wealth of information. And then the final point is, well, maybe not final, Kaggle Grandmasters. So let's talk about that briefly. So Kaggle is a competition. Kaggle is hosted by Google, and they hold regular Kaggle competitions. Kaggle itself does. And people vie for prize money, for status, more status.
But also to upload the skills.
And they learn from each other. So we were just talking to a Kaggle Grandmaster this morning who was like, oh, I have a friend who's a Kaggle Grandmaster. I've actually never met him, but he's
in Melbourne.
He's in Melbourne, and he wants to work with us on XYZ. And so really interesting to see, that cross-functional, and people can be wherever they are, right? As we all know, you go where the talent is, and Kaggle Grandmasters are in every part of the planet. So we're really proud of that we're helping support that. We actually have about 14 Kaggle Grandmasters at H2O.ai that help customers get started. So back to connecting with the community, we're here to help you, but also the Kaggle people themselves, the data scientists there, the universities want to get involved, and also don't just look for data science curriculums, look at math people. People with math degrees are ideal for
physics
this.
Degrees.
Physics. Physicists.
Okay.
Our CTO here has a PhD in physics. We've got nuclear engineers here. These people have the brain to ask the right questions, be creative, and think outside the box, and be fast and analytical. And so connecting to the community, you're going to learn all this. You're going to find out it's not that I need to go hire a PhD in data science or a master's in data science. Connecting to the community, you're going to hear about such a broad section of people and diverse backgrounds, which is really important to getting the answers. So hopefully, we're excited about the community. Again, as Vinod said, open source is where we got our start.
And this community is uniquely built on open source.
And this community is built on open source, and we connect with everyone. We encourage you to do the same. So that's the key takeaway. And we're going to just jump right into takeaway number 4. So technology. So how do you eliminate the talent problem? Not eliminate. How do you minimize the talent problem, the time problem, and the trust problem? So there are technologies out there called automatic machine learning, AutoML. That's what you should look for, automatic machine learning platforms. And then you've got to start thinking about what do you as, if you're a CIO listening to this call, or you're in IT and you're listening to this call, or you're a business leader, you don't know where to begin, or maybe you do. So there's a lot of different options out there. Obviously, we have one. But you have to think through, am I going to go open? Am I going to go open source? Do I have to run this solution in the cloud or on-prem? Absolutely. You can do both. Build or buy. Do I build my own solution, or do I buy one off the shelf? And of course, then you got to think about the data problem. So with that, I'm going to turn it over to Vinod, who is the expert in this on technology considerations.
Yeah, so there's a few different things to think about, right? So if you are starting off fresh on this journey, oftentimes the question is, should you go and buy, they're all kind of interrelated, but should you just go and buy a stack from a vendor and have them do the whole stack in, or should you start with some open source libraries out there to build the knowledge, right? So And
I was going to say there's no right or wrong answer,
exactly, but
actually.
you can do both, right? So we highly recommend you do open source. We, as Ingrid mentioned, we've cut our teeth from open source. So it's always a good sort of consideration. Start with open source just to get a feel for how these libraries work. And great news is they are free. You can just download and try them, and you can quickly get some value out of it and see that, okay, I can do some interesting things. And data scientists love them too, because data scientists share most of their work through open source. So they already probably know a Python library that they like, or they know an R library that they like. They want to try it out, and it's great. But once you quickly get some wins, then the question is, how do we now go to production? So the key with the sort of the dirty secret of data science is that 80% of most projects actually never see the light of the day. So there's a lot of science that happens.
Wait a minute. So there's a lot of science that happens. 80% of the projects don't see the light of day. But that's because it's an iterative process.
Correct. But
you're never quite done.
Absolutely. But the other reason is technological, right? So oftentimes data scientists might pick a library which is deprecated or doesn't have support, and when we say going to production, what that means is really your applications or your sort of mission critical systems are now relying on these models. And when that happens, when you need to reach that stage, your IT concerns or your IT software engineers have a very different set of requirements that they are looking for. So they are looking for reliability, they are looking for scale, they are looking for performance, latency, and they are looking for support. So that's when you might start with open source, but you'll quickly realize that, okay, I might need a vendor to support me so that my mission critical applications, when there's an issue, there's someone to call upon. And sometimes this skill can be, this sort of maturity can be built internally, but oftentimes you'll find that it's better to just go with the vendor. For example, you can find a vendor who's maintainer of the package or maintainer of the open source package. So in the H2O case, our H2O open source library gets used by over 18,000 organizations globally. But a small percentage of those, when they are ready to go to production, when they have mission critical applications running on them, they buy enterprise support from us. And what that gets them is access to data scientists, our support people, and basically 24/7 support on if an issue happens on your production model. The second thing to think about when it comes to cloud and on-prem, obviously, is how fast do you want to get started. So if you are coming into this journey like really new, you might find that cloud will get running up and very quickly, because you basically bypass or shortcut the whole DevOps journey of procuring hardware, putting software on top of it, maintaining them, security, infrastructure, and all those considerations. So if you're starting up fresh, cloud might be a good consideration to really jump the gun. But on the other hand, if you already have a data center, you already have a reasonably mature DevOps practice, then you might just take advantage of your hardware. Obviously, you can save a lot of money by not going to cloud, because you already have your hardware, it's already sort of amortized and accounted for. So, but that's a consideration. And often we find that customers end up doing kind of like a hybrid strategy, so where there are consistent workloads. So after some point of time, you might realize that, hey, I can guarantee that I'll have this much amount of compute workloads for sure, but there are these spikes which you cannot model for. So you might use a hybrid cloud strategy, so jump to the cloud when you have spikes, but use your on-prem as much as possible. And that way you can optimize for your costs and also not have to procure excess hardware.
So, yeah, keep going.
Yeah, and then when it comes to build and buy, this is kind of similar to the open source question. So you do want to build some in-house expertise, and this often helps also hire people, because people want to contribute to packages. People want to build new stuff. But at the same time, you want to sort of have sort of like a good view on what's the time value of money, right? So so the time to insights is critical for a lot of companies, especially in a competitive space. So you want to get really quickly to an answer or really quickly to a solution, and oftentimes that means buying it. And we can buy but also gain the expertise. So you can basically work with the vendors like H2O. We do with a lot of customers. We don't just sell them software. We also teach their data scientists. We often run training programs. We give them tutorials. We give them test drives. So they bought the product, but they also learn along with when they're using the product. And finally, data. Of course, is critical, right? So understanding how you save your data and how do you make it accessible. So there's obviously a lot of considerations around data governance, data privacy, data access, and lineage. So these are all critical pieces, and especially with GDPR and the California privacy laws and more privacy laws coming into play, you need to be really cautious about how you save your data and how you make your data accessible to your employees. So obviously you want everyone should be able to look at the data and get insights out of it, but you should also have those guardrails to sort of put into place so that you don't accidentally leak data or you don't accidentally see something that you're not supposed to. But also, another thing to remember is from a data science perspective too, you want to be you have to understand basically how good your data is, right? So the data quality piece also comes into play. If your data has known issues or if there's missing values and a lot of errors, that might give you bad results, garbage in, garbage out, right? So having that awareness and creating processes so that you know that, hey, how good is a particular set of data that I'm going to be using for a particular set of models, and having a process to sort of keep checking that so that if you know that at some point your data is drifting or changing, you can sort of remodel or recalibrate your model.
So that is definitely all these technology considerations that your data science and IT teams are going to need to consider. As a business leader, you may or may not be thinking about it, but there are costs associated with it, right? Nothing comes for free, meaning that, you know, if you want to get results, you're going to have to invest.
Yeah.
And so you may already have all the infrastructure, you may already be on cloud, you may already have all of this, you may have all your data. So that's the good side of it, but you still need to invest. And then, you know, as Vinod said, I think one of the keys that the last mile, right, which is trust in the data and thinking about the data because of GDPR and the California laws, which are going to be starting to roll out probably. We're going to see more of that across the U.S. and across the world. You know, the idea of trust in AI, right? So how do I trust a model? Where's the bias? What's going on? You know, we hear it's not fair. We hear you know, we can't trust it. We're a regulated industry. So explainability is a big field right now in AI, and I believe that H2O.ai is in the forefront of leading the charge to really try and help people interpret and explain their models and give regulators the documentation that they're looking for. So explainability is certainly, we could spend hours on this talking about fairness and bias in the data, but I would say, and you see this key point here, humans, right? You're never going to take a human out of the loop. That's our assertion, right? You need, as Vinod said, garbage in, garbage out. If a human is going to put bias into, humans put bias into data, right? This happens. Humans take fairness and you know, what's fair to you and I may be different to somebody else. So humans have to be in the mix to kind of oversee not only the AI, but each other. And so when we talk about AI and data science and machine learning, we want the human element to be in there because humans still have the ability to look at an answer that a model might be giving them and say, wait a minute, that's way out of bounds from what I'm thinking, or that doesn't make any sense. So an example of that is, let's talk about like credit scoring. So let's say you get a credit score, it's phenomenal, and the AI says you're eligible to receive $1 million loan, right? Now, if you just let the AI go, that person might get $1 million, right? You can't have that happen, right? So a bank can't let that happen. They have to still check to see, you know, how did the model how did we arrive at that model? Why did it indicate that about that particular individual? So really, you know, a human has to be in the loop in terms of looking at the models, understanding what's happening, and you need to look at an AutoML platform, and we have one called Driverless AI, that helps you interpret that model, that documents the model, that provides reason codes to regulators in regulated industries, which include healthcare, banking, and other industries. I mean, fair lending, Fair Housing Act. There's, you know, hundreds of regulations out there in the U.S. and across Europe. You know, you need to be, and across the world, you need to be looking at those regulations and being able to give a regulator or a lawmaker a reason why a particular model was scored the way it was. And that's where, you know, a platform that does that automatically will be helpful, but also have a human in the loop, making sure that you're not missing something, that you got to put some guardrails on it. So trusting in AI is a very complex subject, but it's very simple when you think about it. It's put a human in the loop from the beginning to the end of the process, put an automatic machine learning platform in there, and then really look at the documentation that's being generated, look at the regulations that it's adhering to, and really the technology can help humans make better decisions. But
Yeah. No,
You're itching to say something there, Vinod.
no, just to add to what Ingrid said, right? So, with trust, so trust is fundamentally, we're talking about basically trust for humans, right? So you're not talking about the machines know what they're doing in a way, right? Algorithms are basically doing what they're doing, but really when you talk about trust, we are talking about a human-centric trust mechanism. So what that means is creating explanations which not even necessarily layperson, but human can understand and articulate, and that means that you have to document the results that you're making, make the decisions that the model or the algorithm made in the process of modeling, and then explaining why those decisions are made. And this will often uncover like really interesting things like, sometimes completely unexpected things like you pointed out. You might see that your data has bias in it. Just as an example, as you pointed out, historically, say a certain group of people or a class of people may have not gotten credits because of different reasons, right? So, and if you start using the same model to build same data to build future models, you will keep sort of reinforcing that bias in the data. But you might want to sort of have a human, and this is where basically you might say, I'm going to overrule the AI's decision or the software and machine learning model's decision because I know that the reason the model made the decision is because of past data, but I know that I want to sort of cover for that bias or sort of fix that bias. So often it can just be a rule engine that just is overruling the decision of a machine learning model. The other part of this is also goes back to the classic Occam's razor, right? Oftentimes, the simplest explanation is often the right explanation. What that means in machine learning terms is that the simplest model that gets you the best accuracy is often the best model. So this is a great example that you see in Kaggle all the time. If you look at the Kaggle leaderboard for a competition, you'll find that the top sort of 10 percentile of results are all within 0.1%. So they are all so close to each other, they're winning on like 0.01% decimals, right? So, and at that point, the question to ask is, hey, is it worth the gain in complexity to get that additional 0.01% lift in accuracy? And the answer most times in industry is not. You go for the simplest model over there, which can get you 99% accuracy of the most complex model. So another good example over here is, I don't know if folks remember, there was this famous Netflix competition about 10 years ago where they put this whole massive data set out there and asked people to beat the recommendation engine. And the winner built a really complex model, which actually never got used. They actually picked I think the person who came fifth or sixth, or the team that came below the rankings, but they had a model which was much simpler but good enough. So the cost of complexity can be significantly high, especially if you don't know what kind of edge cases there might be in your models, in your data, right? So, so picking simpler models, which are more explainable, which have more constraints, which are human understandable, and which can basically overrule if needed, right? With some sort of guidance and guarantee. So that's what constitutes trust. And obviously, this is a huge topic, and as Ingrid said,
and we're happy to help. And
I highly recommend going to our website.
Go to our website.
There's tons of resources. We've done a lot of webinars on this topic. I highly recommend you.
And we have a number of our customers have spoken on the topic at many of our events, and we'll be talking about that even further. But go to our website, and you can see explaining explainable AI and the whole topic of this. But this is really important. You got to put it into your thinking when you embark upon an AI strategy, because people are going to say, I don't trust it, I don't know it, I don't get it. And that's part of going back to the first thing, creating a data science or a data culture. You got to make sure that, that is addressed, step one. Make sure that you're asking the right questions, that you're framing the questions appropriate, not a broad scale, like just sprinkle a little AI on it. That's not going to get you an answer. Making sure you're connecting to the community and being constantly learning. Think about the technology, and this is where the IT guys and gals and the data scientists come in, the analytics people come in. They've got to think through the long-term effect. There's easy ways to get started in the cloud, but you really want to, you got to think, are we going to be in the cloud long-term? Are we going to do a hybrid approach, et cetera, et cetera? And then finally, trust in AI, the 5 key takeaways. Really, you've got to think about trust in AI. Think about, what does that mean? It goes back to, actually trusting your team and being part of the culture and saying, yes, we get it and it's okay. So these are just what we've learned over the last several months talking to a number of CDOs, Chief Data Officers, CIOs, Chief Analytics Officers, business leaders across many, many different industries and across the world. So we thought we would share those with you today. And then, so where do you go from here? What's your next move, right? So you need to, again, get started. What problem are you solving? What technology do you need? Who's on the team? How do you get the support to get it done? You need to have, if you're the executive sponsor, you got to bring a team together around you. It's not just you in your office with your team. You got to bring a cross-functional team in. And, we've talked to CDOs that go and talk to their boards about this. This is a critical board issue right now in terms of making sure that they're getting the latest and greatest and keeping on the cutting edge. So, we want to continue the conversation. We'd love to have you join us at an event, at a meetup. Contact us. We should have put our emails on here. Look us up. I'm Ingrid.Burton at h2o.ai. It's probably the fastest way to get a hold of us. Have your people try our platform. We have easy ways to get started. We have tutorials. We've got, free trials. We do POCs, pilots all the time. We've got data scientists that would love to share what they know. We've got people, our own customers, would love to talk to you about, about this, because the more we all evangelize what's going on in the market today, the more we're gonna get even more of a movement here, and more people will be successful. So with that, Patrick, were there some questions?
Yeah, we do have a few questions here.
Excellent.
We can go ahead and start this one. Do you find more customers coming to you to apply new tools to a well-defined business problem, or more who are looking to see what things might be possible with new tools and techniques? Seems that the former is much easier challenge to address.
Yeah, so it's a great question, right? So obviously the former is is like a low-hanging fruit, right? If you already have a problem or a question, like going back to the right question, if you have a question you want to answer, then you have a very clear idea of what you want to do with it. So we do see that quite a bit, but on the other hand, we also see more and more organizations now sort of buying, saying that, hey, if you build it, they'll come. So buying licenses or asking us to come and set up an infrastructure. So then giving it to the data scientists and people who are data aware, saying that, hey, we got now H2O in the infrastructure. It's connected to our data sources. Now go ahead and build some models with it. See what you can find out of it, right? And what that involves often is us coming and doing some trainings in person or webinars or online trainings, and getting the team sort of up level to say, hey, it's all connected, it's all set up. Now just go ahead and play with it.
Yeah, and I would say it's a mix, right? Yeah. There's never 100% this way or that way. But it is good, some of the companies that we're working with, if they just come up with a new set of problems that they're trying to address that they haven't been able to solve in the past, that sometimes works out really well too. So, is there any other questions?
That's the only one.
That was a good question. Contact us, we'll help you get you started if you're interested in getting started. We're willing also to come in and talk to your executive team. Our CEO talks to a number of boards, and he gets invited all over the place, the Fortune 100 all the time, to talk to boards and executive teams, quite eloquent. So we'd love to help. We'd love to see more adoption of AI and machine learning, in particular in automatic machine learning. So we're here to help. We think it's exciting. I'm excited about this. I've been in tech for a long time. It's one of the most exciting areas to be in. And really, because we're getting outcomes, and as I said, we're seeing success, and customers are getting success. And once you get started, we have one customer that, two more stories. I know we're out of time. We had one customer that started off, with trepidation. They weren't sure. They have like 75 use cases and growing right now. 75 different models they're using for customer churn, customer sentiment analysis, next best customer, next offer. They're a major telco. And then we had dinner with I had dinner with two banks, competing banks. And they started sharing notes, and they were like, we want to share the model for fraud between each other. Never heard this before, okay? This is like, because the data, as it turns out, is their competitive advantage. And the models for them, they were like, oh, we should share notes on the model, the models we're creating for fraud detection. I was just floored. So it's happening, and people want to help each other. And again, two major banks. I never thought that would happen, but that's where we see this market going, is it's really collaborative. Everybody wants to share. Everybody can see this future of getting answers with AI that really are going to give you predictions for your business and make you more competitive. So with that, I think we'll close it off. Happy to help. Contact us and join in the conversation. So thank you.
Thank you. Yes, just a final note here. Just want to say thank you to Ingrid and Vinod for taking the time and doing a great presentation. Thank you to everybody who joined us today. The presentation slides and recording will be made available through our Bright Talk channel. We hope you have a great rest of your day.